for today's class. Today we'll see one of the result of Laplace transform. That is, if Laplace of f of t is equal to f of s, then for a positive integer n, Laplace of t raised to n into f of t or f of t into t raised to n is equal to minus 1 raised to nth derivative of f of s. So we'll name this as equation 1 and we'll prove this statement by mathematical induction. That is, the result is true for n equals to 1, n equals to m, and n equals to m plus n. Now, by definition of Laplace transform, we have Laplace of f of t is equals to integral 0 to infinity e raised to minus st f of t with respect to t, and this can be also written as f of s, or you may write it as f of s is equal to integral 0 to infinity e raised to minus st f of t with respect to t. Now, differentiate this equation to differentiating equation 2 with respect to s under integral sign. Integral sign. That is, you have to differentiate the term within the integral. Now, the left hand side, the derivative of this with respect to s, we have as f dash of s, which is equals to integral 0 to infinity d by ds of, that is with respect to f, the function is e raised to minus st, and we treat this function as a constant and we keep it as it is this. Now, derivative of this term with respect to s, as we write it as integral 0 to infinity, the derivative is e raised to minus st with the constant minus t into f of t with respect to t. Now, equals to, take minus sign outside and keep 0 to infinity e raised to minus st t into f of t. Now, this is same as the Laplace transform where the function is given by t into f of t. So we write it as minus of Laplace of, in place of f of t we have t into f of t. Therefore, we write Laplace of t into f of t is equals to minus of f dash of s. Name it that equation 3. Now, this implies that the result is true for n equals to 1. That is, suppose if I put n equals to 1 over here, the given equation, n is equal to, n equals to 1, we have t into f of t, which is equals to minus 1 raised to 1 is a minus of, this is the first derivative of f of s, so we'll have as a f dash. That's what we have, Laplace of t into f of, we have Laplace of t into f of t is equal to minus of f dash of s. Now, the case 2 is for n equals to m. That is, you have to replace the given statement, this, by m. So we have, as the result is true for n equals to m. So we write it as from equation 1, we have Laplace of t raised to m into f of t is equals to minus 1 raised to m into the derivative of f of s, that is nth derivative of f of s. Now, in place of m, so we have to find the mth derivative, so we write it as mth derivative. Name this as equation 4. So, it implies that the result is true for n equals to m. So it verifies that the result is true. Now we go for the last case, that is n equals to m plus 1. So how to find m plus 1? Now differentiate equation 4 with respect to s. Okay. Now we have d by ds of Laplace of t raised to m f of t is equals to d by ds of minus 1 raised to m into mth derivative for the function f of s. Right? Now, or else you can rewrite this term as, also we can write this as d by ds of minus 1 raised to m into d by ds, that is mth derivative for the function f of s is equals to d by ds of Laplace of t raised to m into f of t. Now keep the left hand side as it is and now go for the right hand side. By definition of Laplace transform, we have the RHS as d by ds, keep as it is, and by definition you'll write the Laplace transform for this as an integral 0 to infinity e raised to minus st into the function is t raised to m into f of t with respect to t. Now take the derivative inside the integral, that is 0 to infinity e raised to, or else d by ds of e raised to minus st, and this you treat it as a constant t raised to m f of t with respect to t equals to same thing what we have done for the first case, that is case 1, that is integral 0 to infinity e raised to minus st with the constant minus t into t raised to m f of t with respect to t. Now again take minus sign outside, 0 to infinity e raised to minus st, and you are left with t raised to 1, and this is m. You have t raised to m plus 1 f of t with respect to t. Now take minus sign to the left hand side and you write it as d by ds of minus 1 raised to m into mth derivative for the function f of s is equals to integral 0 to infinity e raised to minus st t raised to m plus 1 into f of t with respect to t. Now the whole value is what? The Laplace transform for the function Laplace of t raised to m plus 1 into f of t. Now we'll see the left hand side. Now this left hand side, this is a minus sign. So minus 1 into minus 1 raised to m, you have as minus 1 raised to m plus 1. So we write d by ds of right? The term, right? And this as a mth derivative ds for a function f of s is equals to Laplace of t raised to m plus 1 into f of t. Now, we'll have the last step as, now by seeing the left hand side, we have as, now we go for this d by ds of some term, we write it as now as minus 1 raised to m plus 1 into d by ds into this, we write it as d by ds for a m plus 1th term, m plus 1 for a function f of s is equals to Laplace of t raised to m plus 1 f of t. So which proves that the statement 1, what is the statement? The statement is given as Laplace of t raised to n into f of t is equal to minus 1 raised to n into nth derivative of this. So the result is true for n equals to 1, n equals to m, and n equals to m plus 1, which implies that the result is true for n equals to 1, m, and m plus 1. Hence the theorem. So I hope that you're clear with this statement. By using the mathematical induction, we prove the theorem. Thank you for watching this video.